Welcome back. I am Anshu and you are watching Bottleneck. This is the Agenti AI cookbook series where we learn and implement design patterns for AI applications using hands-on examples. In our previous video, we explored the reflection pattern in Agentic AI. No matter how well an AI workflow is designed, the first response generated by an agent isn't always perfect. That's where the reflection pattern comes in. It introduces the powerful utility of self evaluation, enabling agents to review their own responses, identify areas of improvement, and refines their output before delivering the final result. This pattern can also be combined with other agentic AI design patterns to create more effective solutions. If you missed the previous video, I have shared the link in the description below. Alright, in this video, we will take a step further by starting the implementation of Smart Solver, an AI agent that reviews and refines its own decisions. A use case demonstrating generate, critic, refine pattern. So what is a smart solver? Think of this as an AI analyst that doesn't stop for at the first answer. It generates a recommendation, reviews its own reasoning, identifies potential flaws, and continuously refines the solution until it meets a predefined quality threshold. The result is more accurate, reliable, and business ready recommendation that reduces the risk and improves decision making outcomes. In this, we will be utilizing memory design pattern and the generate critic refine. Don't worry about memory design as of now. We will discuss this in a detailed video. We will focus on generate critic and refine. All right, now let's take a look at the workflow. The Smart Solver agent follows a powerful generate critic refine workflow to improve the quality of its reasoning before delivering a final answer. So it starts with the user input, providing a puzzle or a text that requires the solution. Then it starts by analyzing and generating the next logical step towards the solution. Instead of immediately accepting that response, the agent enters a critic phase and where it evaluates its own reasoning, checking for logical consistency, accuracy, and potential contradiction. Now, if the step is valid, it is accepted and moved forward to the final result. But, however, if any issues are identified, the agent uses feedback to refine and improve its reasoning. Okay. The revised step is then re-evaluated again, creating a continuous self-correction loop. This process repeats until a valid solution is reached or a predefined iteration limit is met. By reviewing and improving its own output, the agent delivers more accurate, reliable, and trustworthy results, closely mimicking how humans solve a complex problem through reflection refinement. All right, let's start the implementation. Let's import the LLM first from the util that we have. So import LLM utils as my LLM. All right. Now, before we get into the nodes, we need to create the chain. For the chain, we need the output parser and the chat prompt template. All right. So let's import them one by one. So from langchain core dot output parsers import string output parser. Okay, and from langchain core dot prompts, let's import the chat prompt template. Import chat prompt template. Okay, now as before, we had created a method that will be helping us to create the chains. So let's create that helper method. So dev create chain that will take a prompt message. So we will take it as a prompt, which will be of type string. Okay, and it will return a chain. All right, so what it does, it will create a runnable for us. So create a runnable chain using the provided prompt. Okay, and what it is going to return, so it will return chat prompt template from prompt template. Okay, which will take prompt. Now we will pipe the LLM and the string output parser. All right, now we are going to use this to create our chains. So what all chains do we need here? First, we need to generate this step. So we need a chain to generate step. So let's generate the solution. Okay, so generate step chain. All right, now let's call this create chain. Now inside this we will provide a message. You are a solving logic puzzle agent, or you are a puzzle solver agent. Okay, solve the puzzle using, what do we have here? So we will be having the context and we will be having the, and it has to propose the steps. Okay, oh, so let's rephrase it, because we will be not solving exactly, we will be just proposing the steps how to solve it. Okay, so let's rephrase it. Solve a logic puzzle for the given context. Okay, now the context should be the slash n. Let's put it into the next line. Okay, and we will add the value context with a new line again, and propose the logical step. Okay, so it will propose a logical step, it will generate the first solution. Now it could be right, it could be wrong. All right, so now we need a critic chain that will evaluate this generated steps. So critic chain. Okay, that will be using again create chain. Okay, and we will pass on again a method, a message. All right, so we will do evaluate the reasoning step. Okay, so this is what we are going to do here, and we need to have a context that will be coming from the user input. So we have a context. Okay, and the value would be context. All right, let's highlight it with capital. Okay, and we need to have steps as well, because this will be evaluating what the steps that we generated. So we will put in the steps here, which will be coming down from the generate step. All right, so it will be steps, or the step that we have. Okay, Now, what exactly it has to do? It has to check whether these steps are closer to a solution or not. All right, so we need to have a multi-line. We cannot fit everything in one line. Let's add a multi-line statement here. Okay, let's make it multi-line now. So we are expecting it. Does this step moves closer to the solution without contradiction? All right. If it is yes, then as we know that we need to create a branching here, valid or invalid. So we will return either valid or invalid. Answer valid or invalid. Let's make it uppercase. Valid, invalid. Also, we need some explanation why this is happening. Okay. So we will add explained briefly. All right, so now we have a critic which will be evaluating our previous step, and it will provide an explanation why it is valid or why it is invalid. Now finally we have a refined chain that will be refining the response. So we will have a refined chain. Okay, this refined chain, again we will use create chain. Here again we need to have a multi-line comment. So the following step was incorrect. Okay, this will happen after we encounter invalid. So we will provide the context, okay, which will be the context of or the query that was provided by the user, the parser. Then we have the step. So we categorize it as a bad step because it was already marked as invalid. That will be the step. Then we have a critic reasoning whether it is valid or invalid and the explanation that it has. So we put in everything here. Okay, what we got from critic. Okay, so critic. All right, so we have everything in place. Now what do we need to do here in evaluation? We need to have a better step or corrected next step. So we will ask the LLM to provide a correct step. So now the LLM will use its brain, its predicting knowledge to understand the next step, and accordingly it will evaluate and present to us. All right. We have covered a lot in this video and it turns out to be a little longer than expected. So we will pause here for now. This wraps up part 1 of our Smart Solver agent implementation. In the next video, we will bring everything together by building line graphs, workflow, adding the required nodes, connecting the agent's logic, and running the application end to end. You will see how the complete self-correcting agent comes to life in action. If you find this video valuable, please give it a thumbs up, share it with your network, and subscribe to the channel for more practical insights into AI architecture, agentic AI, and real world design patterns. Thanks for watching, and I will see you in the part 2.